So, just, you can fill in or keep going. It says if x of t represents the position of the particle along the x-axis at any time, initially means what equals 0?
T.
T equals 0. Are we okay with that? Yeah, just recap what we already know. What we already know is that we have x of t. If we take the derivative of x of t, what is that going to give us? If we take, this is the position. What happens if we take the derivative position? What do we get?
Velocity.
Velocity. And if you take the derivative of velocity, what do we get? Acceleration, right? Everybody remember that from last semester? Or physics or wherever, right? Okay. So initially means t equals 0. At the origin means what?
V.
No.
V of t.
If you're at the origin,
Oh, x.
your position equals 0, right? You see the difference? T equals 0 means our time is 0, right? If it's at the origin, that means x of t is equal to 0. Okay. At rest means what?
The derivative of t.
Or velocity.
Yeah.
Right? Is this coming back? Or did it ever leave? Okay. All right, if the velocity is positive, which way is the particle going?
Right.
Going to the right. If the velocity of the particle is blank, then it's moving to the left. So if the velocity is what? Negative. Yay.
What does the bottom say, like on the far right?
V prime.
Equals to what?
Here, let's see here. So if I have x of t, that's just our position, right? If you take the derivative of x, that's our velocity. And if you take the derivative of velocity, then we get acceleration. Okay, to find average velocity. How do you find average velocity?
Changes speed.
No. Oh, okay. Let's throw school out of the window. You're driving.
Add up the two ends and divide by two.
How do you find your average velocity?
You have to spell it.
Distance over time.
Change in distance over change in time, right? Everybody okay? That's average velocity. And then when you drive, okay. How do you do change in distance?
Velocity.
Change in position, right? That's your distance over time, isn't it?
Yeah.
So it's your change in it's change in position over your change in time. So if on average velocity, it's the change in distance or change in position divided by change in time. Instantaneous velocity, right? Well, that's not blank. If the acceleration of the particle is positive, then what is increasing?
Velocity.
Velocity is increasing. Okay? Remember, this describes this. So if your velocity is positive or negative, that's telling us that this is either moving right or left. If this is increasing or decreasing. If this is positive or negative, then that's telling us that this is increasing or decreasing. Are we okay that the derivative describes what the actual thing's doing?
Yeah.
Like the sign of the derivative describes what the sign of the actual thing's doing, all right? All right, now I need to scroll. Okay, okay. If the acceleration of the particle is blocked, then okay, this is negative, and that means your velocity is decreasing. Again, the derivative describes what's right above it. In order for a particle to change direction, the blank must change. The velocity must change signs. Are we okay with our little review? All right? Now, as far as our little review goes, now there are three ways that you are given information about velocity. Right? The three ways are, sometimes they just give you an equation. Yes? Yes. Sometimes they give you an equation. Sometimes they give you a picture. Sometimes they give you a chart. Right? Those are the three ways you're given information. And those three ways are going to be prevalent on free response questions. Recently, we've been focusing all about the chart because that's kind of what I've been teaching. But when we start doing like random free response questions, you're going to be given information either in an equation, chart, or equation, graph, or a chart. All right. So if the position is this, how do you find the total distance traveled on the interval? And So so let's revisit. How do we find our total distance traveled? Should we find out where we started?
Mm-hmm.
How do we find out where we started? Plug in 0. So, here's my time and here's my position. So I'm going to plug in 0, and boy, that was tough. What happens when you plug in 0? 4, right? Should we find out where we end?
Yeah.
Yeah, I think it'd be a good idea. So I guess I'm going to plug in 6, right? And if I plug in 6, that's 36 times 2, 72 minus 36 minus 18 plus 4. So 18 plus 4 is 22. I think that's right. I'm glad I recorded me doing really bad arithmetic. All right. So if we started at 4 and we ended at 22, does that mean we went 18?
No.
Why?
For the total distance traveled, not displacement.
This assumes we went efficiently, doesn't it? Right? If you just do 22 minus 4, you get 18. You're thinking, oh, you're assuming you didn't get lost. Right? Well, how do you figure out if you got lost or not?
Finding critical values.
Find your turning points, right? And our turning points are where our velocity equals 0. So let's see. Let's have our velocity. So that's going to give me what? 3t squared minus 2t minus 3. And I want to find out where that equals 0. Oh no, actually, t squared, there we go. And so that's going to give me t minus 3 and t plus 1 equals 0. So I have a critical value at t equals -1 and t equals 3. Which of these do I care about? Three, right? I don't care about the -1 because we're not going back in time. And so what I should have done with my chart is at 6 I get 22. Now I need to, like, this is a turning point. This is where my velocity is 0. So I'm going to plug 3 in. And when I plug 3 in, let's see, 9 minus 9 is 0. That gives me -5. And so now how do I figure out my total distance traveled? I figure out how far I went here and then how far I went here and add them together, right? So it looks like I went 9 here. It looks like I went 27. So altogether I went 36. Does this look familiar? We're reviewing, right? This has nothing to do with antiderivatives, has nothing to do with area, which is why it's called review, right? And this is part 1, all right? Oh, I have the solutions. That's nice. Oh, good. I can do arithmetic quickly. All right? So one way they can give you information is they give you a function, right? And yeah, that's kind of what they can ask about it. The other way they can give you information is they can give you information in a chart. And this starts to look a little like what we've done, right? So the data table below gives selected values for velocities and meter. We got our velocity. And velocity is different per time. At t equals 0, is the particle moving to the right or left to explain your answer? So given this, which way is it going?
Left.
Left. How do I know?
Velocity times.
Can everybody look at this? Like, here's your chart. And if this is your chart, you can see, like, this chart is telling us that v of 0 is equal to -3. So since that's negative, we know it's going to the left. All right. Is there a time in the interval, right, where the particle is at rest?
Yes.
How do we know?
Intermediate values theorem between t equals 0 and 2.
Our velocity is negative, our velocity is positive. We're looking for, is there a place that the velocity has to be 0? Yeah. And so by the intermediate value theorem, there's got to be some spot in between that's your velocity is equal to 0, between 0 and 2. Okay, I'm gonna have to scroll back up. If you've got the whole sheet of paper in front of you, that's fine, but I don't, right? So you use the data from the table to approximate V prime of 10 and explain the meaning of this in terms of motion and show the computations that lead to your answer. So we are answering question 3, but I need to know what the heck is V prime of 10? I don't have a V prime, do I? If I look at my chart, I got time, I got V, I don't have V prime. But how could I come up with an approximation of V prime of 10?
You just think of what V prime is, which is changing V.
All right. So yeah, that's what we're doing. But anytime you see derivative, what is the key word you think of when someone says derivative?
Slope.
Slope. Can everybody okay with that? Anytime someone says derivative, right? Now, granted, if it's like x equals and find the derivative, you just take the derivative. But anytime they give you something that's not a function and they say derivative, you think slope. And so if I'm looking for V prime, I'm looking for the slope of V at 10. Well, how could I figure out the slope of V at 10?
I mean, it goes from 7 to 5 in between that. Maybe.
Well, at 10, right?
Yeah, so it's negative, right?
Yeah, it's going to be negative. But notice how 10 is, doesn't it seem suspicious that 10 is exactly in between 8 and 12? So if you want to figure out the slope of V at some point in between, what you could do is find the slope between these two coordinates. Does that make sense? I mean, the picture that I have in my head is, okay, here's 8, and here's 12. So at 8, I'm at 7, and at 12, I'm at 5, and the graph's doing something, okay? What they're asking me is at 10, they're asking me what's the slope of that tangent line. That's what they're asking. Well, I can't really find that, but if I find the slope between these two dots, that's going to be pretty close to that slope. And that's what you're doing. Does that make sense? So when we go through this, and when they say show the calculations that lead to your answer, you really need to show you the calculations, because on the AP exam, they're not going to give you points unless they see the subtraction problem. So I'm going to do y minus y, so 5 minus 7 over 12 minus 4, so it's at negative 2. Number 12 minus 8 over 4, so I get negative 1/2. What are the units? So we're meters per minute, so what are the units for
Meters per minute squared.
meters per minute squared? All you physics people, is that coming back? Because you have and so this, for question 3, we're going to say that's going to be negative 1/2 meters per minute squared, and you can't do the time unit squared on that one. So far, so good? Okay. Says let A equal no the acceleration of the particle. Is there a guarantee to be at least one time equals c where the interval, in the interval, so that the acceleration equals 0? And that is a full-on AP question. They love to ask this. So let's make sure everybody understands the question, right?
Wouldn't it just be in between 6 and 8?
Why?
Because both is 2 over 2.
It's what?
Like if you do like the y2 minus y1 over x2 minus x1, don't you get 2 over 2?
Well, so I like what you said about, no, not between 6 and 8. What we're looking for a place where acceleration equals 0. We're looking for something that guarantees that acceleration equals 0. Now remember, acceleration is v prime of t, right? Is there some place where the slope of v has to be 0? Yes.
I have to do between 6 and 12 because it goes from going up to going down, and that means it's flat.
Do you see that?
Yeah, so it's probably an 8.
Well,
Necessarily.
we don't know.
It could go up and then keep going. Right.
You don't know exactly where it is. All right, now, better question. fake bonus points. What reason is that?
Because it can.
There is an official official calculus term that I have not used at all this semester.
Goes from,
Critical value?
No,
you haven't used this semester?
I have not used it this semester.
Last semester?
A lot last semester.
It's not the intermediate value.
Concave.
Is it displacement?
No. Mean value theorem.
Mm.
Mean value theorem. Here's what the mean value theorem says. Like you described it. You did an absolute job of describing everything about mean value theorem. You just didn't call it mean value theorem. What you did is you said, look, I got a dot here, I got a dot here. No matter how I connect the dots, right? Because these two dots are at the same level, that has a slope of 0. By the mean value theorem, there's going to be some spot in between here, right? In between here, where the slope of the tangent line equals the average slope. Right? Now,
Assuming if you're given that it's not flat between those two. If they
Yeah.
didn't give you 8 and 7, it could just be flat between the two.
well, no, actually, mean value theorem guarantees there's at least one spot. If it's flat, all the spots are. Okay. All right. If you're a little fuzzy on mean value theorem, don't worry. We're going to do a lot more of that. Oh, look. Remember I said you have to do it with an equation, with a chart, and with a graph. Okay. So here is the graph of velocity. Sorry for the little printout. Okay. So I have the graph of velocity between 0 and 9, and now we have some questions about it.
Hold on, where are we in the packet?
Should be, I've printed front and back.
Oh, it's in the back.
At 4 seconds, is the particle moving right or left, explain. Okay. So what are we doing? Which way is the particle moving, right or left?
Right.
How do I know it's right?
Positive.
Because your velocity is positive. Everybody see that the velocity is positive?
Oh.
This is the graph of the velocity, or velocity is
Oh, I should
positive?
look at that one.
Okay. Everybody okay with that part? All right. Over what time interval is the particle moving left?
From 5 to
5 to 9.
5 to 9, because our velocity is negative. Just curious, is this a lot of review from physics?
Yeah, 9.
Usually when I put this up, the people that have had physics, they had to do a whole lot of these velocity graphs. And so when I'm asking, it's like, okay, this is easy compared to what they made you do in physics. At t equals 4 is the acceleration of the pod. So at t equals 4, so we're here, is the acceleration positive or negative?
Negative.
Why is the acceleration negative? Because the slope. Are we okay that we still have this? We know that v prime of t is the acceleration. V prime is a fancy name for slope of v, right? And so our slope of v is negative, so our acceleration is negative. Okay. What is the average acceleration of the particle between 2 and 4? So how do we find the average acceleration between 2 and 4? Slope, right? So, okay, we find the slope of the green line? Okay.
That's 2.
I think that's 2.9. And this is 4.6.
So, -2/3.
Yeah. No, negative 3 over 2.
-2.
Yeah. So we get negative 3 over 2. And what are our units of measure? So I guess this will be feet per second squared. If the velocity is feet per second, then the acceleration is going to be feet per second squared. Oh. Is there a, oh, this is even better. Is there a is it guaranteed that your velocity, your v prime is going to be, there's a spot where it's exactly equal to negative 3 over 2?
Yes. I mean, value theorem.
Mean value theorem, for the mean value theorem to work, the function has to be nice, which means continuous and differentiable, connected and smooth.
Can't you just like see it out and say no?
Right. Well, but I'm also pointing out, notice it's connected, but notice it's not smooth.
Oh, yeah, it's not nice.
Right, it's not differentiable. And since it's not differentiable, then there's no guarantee.
So on the AP exam, if we say no, and then how we justify it? Like,
You say it's not differentiable at 3.
Wait, so the 4 would be 15?
What?
So the 4 would be 15, right?
What?
Never mind.
What? No. What were you asking?
The answer to 4 is 15, right?
I think it's near 3/2.
It's negative 3/2.
Wait, I closed that wrong.
You have to subtract. 6 minus 9 over 4 minus 2. All right. I've already kind of done this one, and I want to talk about new stuff. So here's your analytic one, and I may have to come back to this later, but this is modeling kind of what we did last semester. At t equals 0, is it moving right or left? That means, like, usually when you have this, you take the derivative, you find out your velocity and your position equation. And once you have all of that, then you can answer all this stuff. And so there's our solutions, more solutions, and more solutions. See, look, Dixie Roth at Pflugerville High School.
She's doing a nice job.
Oh, this is an amazing job. She did a great job. I'm not making fun of her at all. I'm just thinking that's a
That's a funny way to.
I would hate to live there.
yeah. That's a unique name of a town, right? Probably somebody famous in Texas. All right, and now we get to some new things. That was kind of review. Now we get to talk about some new things. Some new things, not a lot, but some new things. So speed's the absolute value of velocity. It tells us how fast something's moving without regard to direction. All right. So actually, some of these are really silly questions. What effect does absolute value have on numbers? Makes them all positive. What effect does taking absolute value of a function have on a graph? Oh, that's important.
it makes it not differentiable.
Usually, not always.
If there are negative numbers in the graph, it makes it not different. If there are negatives, then it turns.
Really? What about the graph of y equal x cubed?
Non-differentiable if you take the absolute value. That's what I said.
Or sorry, it makes it not differentiable because then it turns it into sharp. Where it
No, and my claim is it doesn't always. What's the graph of y equal x cubed look like? That's this, isn't it?
Oh yeah, so.
And if you put absolute value bars around this, it flips this up, right? Oh, look.
It sometimes makes it.
Most of the time it makes it non-different. Okay, but I do like the fact you're saying that because you're realizing that it makes points, right? It flip. Are you visualizing it as flipping the bottom up?
Yeah.
Okay. Does everybody see that? When you take the absolute value of something, it flips it up. It normally makes something look weird, all right? Okay. Retracing plot the speed graph. Oh. Well, okay, so this is kind of boring. This is your velocity graph. Is there going to be any change in my speed graph? Well, no. The only difference between speed and velocity is when velocity happens to be negative. Is my velocity negative at all?
Oh, you mean like it'll switch them?
Yeah. So in this case, the velocity graph and the speed graph are exactly the same. So in this situation, velocity is positive and increasing, and because velocity is increasing, we know acceleration is positive. Okay. By example, graph of speed, and label as we include speed is increasing or decreasing. So if we look at this, hey, since our speed is increasing because everybody's doing what they're supposed to do. Actually, I'm going to skip this. You remember when we talked about if you can tell if something's speeding up or slowing down? How do you know if something? How do you determine if something's speeding up or slowing down?
velocity, equal to velocity and acceleration if the,
If velocity and acceleration are doing the same thing.
yeah.
If velocity and acceleration are both positive or both negative, then you're speeding up. If they're different signs, then they're slowing down. That's what this whole thing is, and I'm gonna skip that because I don't need that. I gotta get to the new stuff. Okay, and worksheet part 3. Yay, yay, yay. I'm glad I'm recording this. I don't even have answers. And so now we need to talk, this is new. So in my last 12 minutes, I actually get to something new today. Unfortunately, the new stuff is this, not very much. Okay, quick review. Speed's the absolute value of what? Velocity. That part's easy. If the velocity and acceleration have the same sign, okay, or increasing, okay, velocity have a different sign, speed is decreasing. All right, now let's talk about this. These three things. This summarizes the new stuff. And this is a big deal. Okay? Is there 3 or 4 of them? There's 3. Okay. All right. So we know this little symbol means antiderivative, right? So if you take the antiderivative velocity, guess what you get? So remember, let's think about last semester. You had your position, and when you take your derivative of the position, you get your velocity. You take your derivative of velocity, you get acceleration. So if you take the antiderivative of velocity, guess what you get? You get position. Everybody okay with that? And it's a function, like it gives you a position, right? You also have that plus c. Remember when you take an antiderivative, you get a plus c? Basically, you've got to figure out what that c is, and there's some other, we're going to come into some other things. But I really want to talk about these guys. And in particular, this has some interesting implications from one of the first problems that we did. Okay, so if I take this symbol when you have numbers means area, right? Right? And this is what I've been hinting around for the past couple of class periods, and now I really have to say it. And I'm going to have to say it many, many times. But if I were to say, if I were to put numbers like from 1 to 4 of v of t, here's what this tells us. This tells me how far I traveled from time 1 to time 4. Right? This tells me displacement. Anytime you compute the area under velocity from here to here, right? You compute that. That tells you your change in position. That tells you your displacement. Right? Does it tell you your total distance traveled?
No.
Okay. Are we okay that displacement and total distance traveled are 2 different things?
Yeah.
And the problem is, if you just look at velocity, sometimes your velocity is above the x, sometimes your velocity is positive, sometimes your velocity is negative. And if anytime your velocity is like a combination of positive and negative, that's when you're going back and forth, you get lost. All right? So if you just compute this, that's going to tell us our displacement. Comparing that with, what if I do 1 to 4, but I put absolute value bars around here? First, do we recognize that the absolute value of velocity is speed?
Yeah.
Okay. What this does is cuts out all the negative, and so when you compute this, it actually tells you total distance traveled. And this is and that's, when the first time I heard that, that wasn't intuitive to me. If I think about the picture, it is, right? But just finding area of velocity doesn't tell you, that just tells you how far you walked. It doesn't tell you, that tells you your distance from where you started. This tells us how far I walked, and that's a big deal. All right. How are we with our little review of particle motion? Okay. The part two had to do with this area stuff.
Yeah.
Okay? And so now, what you're going to do